In this video, I'm going to go over problems 11-2 to 5. Your homework is 7 to 13, and it's going to work on simplifying rational expressions. So in 11-2, it states that Mr. Wonder claims that anything divided by itself equals 1, as long as you don't divide by 0. So he states that 16x divided by 16x equals 1 if x doesn't equal 0. And that's true. The reason that that's true, which we know it's true, but one of the ways we first learned division was by multiplication, because 16x times 1 is equal to 16x. Basically, fraction busting that, and you get the 16x times 1. X can't equal 0 because we can't divide by 0. And then Mr. Wonder considers x minus 3 divided by x minus 3. And he's asking the question, does this equal 1? So this does equal 1. But it says what value must be excluded. And so it equals 1 if x doesn't equal 3. The reason being there, if x equals 3, we have 3 minus 3 divided by 3 minus 3, so 0 divided by 0. And we know we can't divide by 0. I'm going to skip part D, create your own, anything divided by itself, except include any exclusions. Part E, it just shows z divided by z times xy is equal to xy. And with the z divided by z, they have it as the big 1. So really this is 1 times xy, and anything multiplied by 1 is still itself. So that is true. That was just kind of reminding you anything divided by itself is 1. You can't divide by 0. And then the idea of our big 1. Okay, so here we're going to simplify on number 3 and state any excluded values. There's 8 parts. So A, I might not do all 8 parts, is x squared divided by x cubed. X squared is x times x. X cubed is x times x times x. So the idea that your book is using, which some of you can just kind of simplify right away, is they're saying, okay, this x divided by this x is 1. This x divided by this x is 1. And so really we're left with 1 times 1 times 1 over x. This is 1 over x. The x stays in the denominator, which is just 1 over x. A lot of you are just going to cross these x's out, and I'm totally fine with that. That's kind of what we are expected to do. It's just reminding you of the baby steps that got us here. So x divided by x times x divided by x times x over 3. Same idea. This is a 1, this is a 1. We know multiplying by 1 doesn't change anything, so our answer is just x over 3. Oh, going back, I also forgot to state the excluded values. Here, x doesn't equal 0. Can't divide by 0. And here, x doesn't equal 0. Because if it equaled 0, it's fine in our answer, but here it wouldn't have been okay because we would have been dividing by 0. Part C, we have x minus 2 divided by x minus 2 times x plus 5 divided by x minus 1. So these x minus 2's, these are a big one. It's the same thing, numerator and denominator. And our answer is x plus 5 divided by x minus 1. These x's don't cross out here. Don't try to simplify this. Some of you will cross out the x's. So I'm going to put does not equal 5 divided by negative 1. Your x's do not go away. Don't do that. Just doesn't work that way. On this problem, if I plug in 2, the denominator is 0. So x doesn't equal 2, because 2 minus 2 would give us 0. And here, 1 minus 1 is 0, and x also doesn't equal 1. So x can't be 1 or 2. If I plug in 2, I get 0 here in this denominator. And if I plug in 1, I get a 0 in this denominator. Let's see, part D. We have 9 divided by x times x over 9. So remember, to multiply fractions, you multiply straight across. Numerator times numerator, denominator times denominator. So this is 9x divided by 9x, which is just 1. Again, as long as x doesn't equal 0. Some of you are going to skip this middle step, and I'm good with this. You're going to say, okay, I have a 9 on top and a 9 on bottom. It doesn't matter if they're in the same fraction or not because we're multiplying. We'll work more on that later, so if you don't know what I'm talking about, go ahead and ignore it. But some of you will go, okay, that's a 1 and that's a 1, that's a 1 and that's a 1, and everything cancels out and we're left with just 1. Let's see. E is h times k over h. Same idea. 1h on top and 1h on bottom cross out. So we're left with k, or hk. Again, as long as h doesn't equal 0. Because then we would be dividing by 0 in our first step. You always look at the first step. What would make this 0? You could do your excluded values before you do anything else if you wanted to. Alright, on F, 2m minus 5 times m plus 6 divided by m plus 6 times 3m plus 1. So this is what I was saying. I can do my excluded values right away. To make this first fraction 0, or first denominator, I'm sorry, first part here 0, we'd have to have a negative 6. So m doesn't equal negative 6. And then in this one, m doesn't equal negative 1/3. And the way I got that negative 1/3 was 3m plus 1 equals 0. Subtract 1, 3m equals negative 1, and m equals negative 1/3. So again, it's just setting each factor of the denominator equal to 0. On this problem, an m plus 6 in our numerator and denominator cross out. So we're just left with 2m minus 5 divided by 3m plus 1. Part G, 6n minus 2 squared divided by n minus 2. So again, I can do my excluded value right away. N can't be 2. 2 minus 2 would give me a 0 there. So remember, squared is times itself. If it helps you, you can write this as 6 times n minus 2 times n minus 2 divided by 3 times n minus 2. So an n minus 2 and an n minus 2 go away. And then 6 divided by 3 is 2, which some of you will kind of go like this. Some of you will just say, well, 6 divided by 3 is 2, so 2 times n minus 2. And last one here, h, just did them all. 3 minus 2x divided by 4x minus 1 times 3 minus 2x. So, again, excluded values. M doesn't equal 1/4, which if you set 4x minus 1 equal to 0, you'll get 1/4. And I don't know why I said M, was looking up above, sorry. X doesn't equal 1/4, and X doesn't equal 3/2. If you set 3 minus 2x equal to 0, you get 3/2. So 3 minus 2x, it's like it has parentheses around it. That whole thing crosses out with that whole thing. But remember, this 4x minus 1 is in our denominator. And what we're left with on top is really a 1. This is 1 divided by 1, or just a 1 in our numerator there. Okay. So problem number 4. Mr. Wonder tries to simplify 4x divided by x and 4 plus x divided by x. So he says since x divided by x equals 1, then 4x divided by x equals 4. So his rationale is x divided by x equals 1, which implies 4x divided by x equals 4. Is that true? So it says substitute 3 values of x into the original expression to justify your answer. So we're going to plug numbers in for x here to see if this is true. Again, this is like a question mark. So we'll just say if x equals 5. We can't do 0. We can do any other numbers we want. So if x equals 5, we have 4 times 5 divided by 5. 20 divided by 5 is equal to 4. Works there. Let's see, if x equals -3. We have 4 times -3 divided by -3. -12 divided by -3 equals 4. Works there. Let's do if x equals 1/2. We have 4 times 1/2 divided by 1/2. So 2 divided by 1/2, that does equal 4. So that works too. So yes, this is true. It worked, which hopefully we already recognized. But part B switches it up a little bit. And he wonders if 4x plus x divided by x is equal to 5. That's his question. And if you don't think it's equal to 5, what do you think it's equal to? Kind of ask yourself that. Do you think it's equal to 5? If not, what is it equal to? So again, substitute 3 values in for x to justify your answer. So if x equals 1, 4 plus 1 divided by 1 is 5 divided by 1. That's 5. That works. If x equals, 3. 4 plus 3 divided by 3 is 7 divided by 3. That doesn't equal 5. If x equals -5. 4 plus -5 divided by -5. -1 divided by -5 is 1/5. Also doesn't equal 5. So this is not true, or no. 4 plus x divided by x doesn't equal 5. So 4 plus x divided by x, that's already simplified. It doesn't get any more simplified than that. The reason being, it's kind of, since this is addition in the numerator, this is a binomial, so it's like there's parentheses around it. It can only cross out if I have a 4 plus x in my denominator. So that's kind of what part C is asking. So because it's addition, it can't be simplified. This was multiplication, so it can be simplified. So part D says x squared plus x plus 3 divided by x plus 3. Does that go to x squared? Or the other expression they give is x plus 2 times x plus 3 divided by x plus 3. Does that go to x plus 2? So which of these is written correctly? Explain how you know. So this one, x plus 3 in the numerator and denominator, again, there's like parentheses that are invisible. Those cross out and we're left with x plus 2. This one works. What they tried to do here was cross out the x plus 3 and the x plus 3, but you can't do that. Again, this is addition, so you have to think of this whole thing coming as one term, as that trinomial. And then same thing down here. So this is no or not true. This is not simplified correctly. With addition, it doesn't cross out unless it's the exact same expression in the numerator and denominator. So 11-5, work with your team. Obviously that's not happening, that's why we're going over this. To simplify each rational expression below, showing any ones. Verify that your simplified expressions are correct by substituting values of x. For each expression, assume the denominator is not equal to 0. So we don't have to do the excluded values here. So on part A, the numerator is x squared plus 6x plus 9 divided by x squared minus 9. Okay, so take a few seconds to think. What do you think we do here? Nothing can cross out right now. We can't cross out the x squareds. We can't cross out the 9s because this is one term and this is one term. It would have to be the whole thing. So what do you think we could do before we can simplify this? And look back up here. This one wasn't simplifiable. This one was. What's the difference? So what you have to do on a problem like this is factor it to make it look like this. If it's broken into multiplication and there's this common factor in the numerator and denominator, they'll make a 1. So this numerator factors into x plus 3 times x plus 3, or x plus 3 squared. And the denominator factors into x plus 3 times x minus 3. This is a difference of squares. Hopefully you can factor that one quickly. This is a perfect square trinomial. Most of you might not know that shortcut, and that's okay, but we all know how to factor. So right here, x plus 3 over x plus 3, those make a big 1, and we're left with x plus 3 divided by x minus 3. This is your answer. Again, these cannot simplify. X plus 3 and x minus 3, this does not simplify to negative 1 because it's a plus and a minus. It doesn't work that way. And if you're like, why not? I feel like it should. Look back up here and kind of try to plug some numbers in. If x is 0, it works. But if x is 1, you have 4 divided by negative 2. So it doesn't, this can't be simplified. Same thing. It's like these parentheses are there. And if you want to write them, write them. Part B, we have 2x squared minus x minus 10 divided by 3x squared plus 7x plus 2. Nothing can factor right now. Or, sorry, not factor. Nothing can be simplified. We can't cross anything out to make a big 1, so we have to factor. So I'll do the numerator first. So 2x squared negative 10. So negative 20x squared negative x. If you don't use the diamond, remember that your diagonals They multiply to negative 20x squared, which is the same in the numerator there, and they add up to negative x or negative 1x. So we get negative 5x and 4x. Which makes the outside of my box x, 2x, negative 5, and 2. So my numerator, the top, the 2x squared minus x minus 10, factors into 2x minus 5 times x plus 2. In my denominator, now I have to do the same thing, still have to factor it. It won't always happen, but on most of these problems, you're going to have one of these factors show up in the denominator, because that's the only way to simplify. If one of the factors is 2x minus 5 or x plus 2. And if not, it can't be simplified. So here we have 6x squared and 7x, which makes these x and 6x. So I get x here, 3x, 1, and 2. So 3x plus 1 and x plus 2. So my x plus 2's, you can see here, do end up being the same. And I simplify this to 2x minus 5 divided by 3x plus 1. Part C, 28x squared minus x minus 15 divided by 28x squared minus x minus 15. I could factor the numerator and factor the denominator, but if you just look at this one, it is the exact same on top and bottom already. So they just cross out, and this is equal to 1. It was the same thing divided by itself. And the last one down here, x squared plus 4x divided by 2x plus 8. Both of these have a common factor for your factoring. So on top, we see that the common factor is x. So if I factor out an x, I get x plus 4 in my numerator. My denominator, I have 2x plus 8. So those are both divisible by 2. If I factor out a 2, I have x plus 4. And so here, same thing, my x plus 4's are the same on top and bottom, so those cross out or make a big 1, and we're left with x divided by 2.